flying at the top of what we call the troposphere, the lower part of the atmosphere, which is, from a weather point of view, the working layer of the atmosphere. Ozone is above that, and ozone is important because it shelters us from a lot of UV radiation. But the weather part of the atmosphere is just somewhere between 11 and 18 kilometers thick, depending on where you happen to be, at the poles or the equator. And we're at a very interesting spot on the place in that thin atmosphere, which is greatly exaggerated here in showing the cells of the atmosphere. We live very close underneath the polar front, the boundary between the polar air from the north and the mid-latitude air that often covers the Great Lakes and further south. So we live in a very interesting place within the Earth's atmosphere, where the weather can change very quickly. And if I tell you that there was 6 inches of snow down at Niagara today, you will realize how far that cold polar air can reach after it had been warm enough for the daffodils to be blooming in Niagara under 20 degrees sun. And that's that change from quite cold to quite warm is part of the characteristics of living under the polar front. If we look at today, and this is Wednesday, April 21st, so this is today's boundary between that cold polar air, which you see here in blue. And if you look at the temperature scale on the right, you'll see that most of that blue air is at about somewhere around about -10, maybe a little warmer than that, but certainly below 0. But the only part that's really cold, down in the -30s, which is the purple color, is over Greenland. The North Pole, which you might be able to see if you can see the dotted crossed lines, if I can make my cursor move. Here's the North Pole. The air around the North Pole is not that darn cold at the moment. -10 is pretty warm for the North Pole, but it's the time of year when the sun is getting higher in the sky, and the North Pole is heading towards 24 hours of daylight. So it's warming up in the north, and the cold air, which can come down at -30 and 40 and even colder than that during the main part of the winter, is now warming up. And that warmth is being amplified by the greenhouse gas effect, and it's producing anomalies. If you look at this is the temperature today compared with what the average was between 1979 and 2000. So that's what's meant by the 1979 to 2000 base, which is up on the top left-hand corner, the one-day average, just below the top of the screen at the left-hand corner. It's warm. It's warm in the north, especially over the land. The ocean hasn't warmed that much yet, because remember, it's still covered by ice and is reflecting the sun. But the snow on the land in the north has begun to melt, and land areas are beginning to absorb the warmth of the sun. And those dark brown colors tell you that the temperature up there today is in the neighborhood of 10 degrees, even as much as 12 degrees warmer than the average of the 1979 to 2000 base. And that warming is, as I say, a combination of the effect of the higher sun in the sky and the greater radiation from the sun, but it's also a reflection of a result of the absorption of energy by greenhouse gases. And just as a quick reminder and a refresher, this is how it's working. The solar energy passes through the atmosphere, reaches the earth, and it's warming the land, as I mentioned, and it's reflecting off the snow, as I just mentioned. But when that warmth tries to radiate back out into space, it radiates out with the same wavelength pattern that a hot frying pan does. whereas the sun radiates through the atmosphere with quite a different wavelength, quite a different sort of warming strength, if you like, and the re-radiated energy that the Earth is trying to lose to maintain its temperature is a large part of that is captured by the greenhouse gas and returns back to Earth. Both of those processes then are warming the North right now. And during the summer, and this begins to make a difference to our weather in Northern Ontario under the area of the polar front. During the summer, the sun's radiation plus the greenhouse gas warmth will melt more of the snow than it did in the past. So if you look at that little yellow, the yellow line, that's the median extent, the average extent, if you like, between 1981 and 2010. And probably all of you listening who are aware of climate issues will know that the ice coverage in the Arctic is not only getting less in area, but it's also getting thinner. The ice that used to be 10 years old has been melted, and the ice over the Arctic at the moment is 1 and 2, and it's 3 years old. So it's losing its thickness, and it's losing its aerial extent, and that is an important influence on our weather in the north. This is what the Earth looked like in November 23rd. It's the same site, the Climate Reanalyzer. If any of you want to go to this, it's a very interesting site. There are all sorts of different parameters of the Earth's weather systems that you can find there. You can see the menu on the left there. But what I want to emphasize is the importance of ocean water over the Arctic. This is November, right? And that air over the Western Arctic is relatively warm. It's about -10. This is November over the North Pole, right? November over the North Pole. And that air is being warmed by the radiation, the warmth coming from the water that used to be covered with ice for most of the year, but is now open for longer and longer, absorbing sun's energy and then radiating that sun's energy back into the atmosphere, even in November. And look at the way that Hudson Bay, the warmth of Hudson Bay is warming the air above it, so that the purple air, the -30 air, penetrating down from the north, from the land areas of the north, not the ocean area, but the land area of the north, is being warmed as it reaches Hudson Bay. So Hudson Bay is our refrigerator in the summer, but it's also a source of warmth for the late autumn air, and that makes a big difference to the kind of climate change that's occurring in the north of the province. And part of what's also happening, which is making a difference to the weather of the north and to the impacts that are being felt in the northern First Nations, is the shape of the boundary between the cold polar air and the warmer air to the south. Back in the 1960s, 50s, 60s, 70s, maybe into the beginning of the 80s, the boundary was much like the boundary of a hat on your head. It was a pretty straight, regular, almost circular boundary. That has now changed into a much more convoluted boundary, which brings warm air to the north and sends cold air to the south. It's this kind of pattern that the Texans were suffering from in February, was it? February, when their pipes froze and they got temperatures down to -20, when it was as cold in Texas as it was in Ottawa. And the reason for that is the density difference. The density difference between the warming colder air from the north, not as cold as it used to be, warmed by greenhouse gases, as well as by the sun, that air is now less dense than it used to be historically. And the density difference between the Arctic air and the mid-latitude air is less. And physics leads to that convolution. So a little bit of background to the influences that we're feeling to the weather patterns in the north. So let me show you an impact of that kind of change of pattern. And this is the 7th of March of 2017. The date is down at the bottom there. The Intellicast is a site if ever you want to go there yourself and look for maps like this. And the temperature in up on Hudson Bay, so here's Hudson Bay and here's the Hudson Bay coast. And I'm going to take you to Fort 7, which is right up here. So I'll take an opportunity to show you the place, show you the location of Fort 7, the northernmost community in Ontario, where I've had a chance to spend time until this COVID thing came along. I was there every year for about 10 years, making at least one visit, if not two. So there's Fort 7 up there then, and the temperature in Fort 7 was much like the temperature down in Arizona, down in the southern states. In fact, Fort 7 was warmer than some of these places that had patches of purple over them way down in the south. And that was because one of these convolutions of warm air spread up toward the north. So the polar front had this kind of convoluted pattern to it. And what was the consequence in Fort 7? Well, here's another view of that boundary. This is the so-called northern jet stream, which is the boundary of the air between the polar front, the polar air, and the mid-latitude air. There's Fort 7, and that's what it was doing in Fort 7. I happened to be up there during this time. It was the first day of spring, 2012. 9 degrees. 9 degrees. The regular temperature, the average temperature at this time in March would have been about -10, something like that. So it was much warmer than usual because of that warm air coming up from the south. It rained, and it didn't just rain; it rained on frozen ground. And this is one of the climate change impacts of more rain on frozen ground. This is a ditch that was filled with water that ran off from the frozen ground as though it was concrete and melted some of the snow that it carried with it. And that red building on the left is the water treatment plant in Fort 7. And fortunately, the rain stopped in time for the ditch not to flood the water treatment plant. But it darn nearly did. You can see how close it is, and you can imagine if it had rained for 3 more hours, then the water treatment plant would have been flooded. So infrastructure, buildings are becoming vulnerable to an increase in rain on frozen ground in the north. This is an important impact that needs to be considered in the design of the drainage system in communities. And Fort 7 actually, I just got an email from the chief there last week with details of a drainage study that they've just had done, and the reason for that drainage study is what you're looking at. At least that's what you're looking at is part of the reason for that drainage study. The other reasons have to do with the size of the culverts in the community. This is a projection of Fort 7 days when it'll be below -25. In other words, cold days in Fort 7. What's the winter like going to be in the future? Today in 2010, there are 60-odd days below -25.
Yep.
Somebody needs to mute themselves.
No. Brown face.
It's good if people mute themselves. Great. So somewhere in the neighborhood of 60 days below -25 right now in the beginning of the 2000s into 2020. If we continue with the business as usual emissions, then by 2050, we'll be down to 28 days below minus 25. Less than half of the minus 25 degrees at the days at the moment. If, on the other hand, the kind of talks which are beginning tomorrow between the Chinese and the Americans, and the plans of that are being launched tomorrow in the UK and by the European Union, which are ambitious, very ambitious, if those plans actually turn out into reality, then there's a chance that the reduction of days to just a few more than 20 by the end of the century will in fact be twice that number, up to 42. And the relevance of these very cold days, we'll talk about a little bit when we come to talk about winter roads. But what we're doing now, the talks that were taking place now, have to do with what it is, what kind of climate the next generation will have to live with. We're not making changes for our own benefit. We're making changes in our emissions for the benefit of our kids. And that's the kind of long view that we need to be taking about when we'll see benefits. It's a sort of long view that appeals to Biden, that Trump had no use for, whatever. Now, I want to take you up to Fort 7. In reality, this is what the community looks like. Hudson Bay is out on the to the north of the slide there. You're looking out into to Partridge Island, which is a big island just before reaching the bay. This is the middle of May. It was about May the 14th, May the 15th of 2 years ago when I was up there and flew with the chief to inspect the river ice, because ice jams are a potential danger in Fort 7. And one of the places I want to take you to is at this end of the community, which is where the Hudson Bay Post was built. And I'm going to show you what's happened to the land of the Hudson Bay Post and what's happening now. This is a fascinating and interesting community. There's Partridge Island. This is it from Google Earth. You're looking down on the boundary between Partridge Island and Hudson Bay. And this land is new land. In fact, the land around Hudson Bay is, whoops, I don't want to go there quite yet, is rising faster than sea level is rising. So it's one of the very few coastlines in the world that is growing. That's new land, and technically and legally, one or two of you have got any legal background might be interested that this land is actually Nunavut. The land under the water of Hudson Bay is Nunavut, not Ontario. So there's something for the lawyers to to talk about here. So here is the community, and we've already talked about how rain on frozen ground is one of the impacts that they're dealing with. This is another of the impacts, and the melting of permafrost. If you look at the bank that's below the buildings of the community, this is what you see. This is mud that was the mud of the floor of Hudson Bay, but remember the land is rising, so the floor of the bay has risen. And this is sand and gravel and silt that was part of the beach at the time. So the land on which the community is built is old Hudson Bay mud with a bit of sand and silt on the top. And the importance of what you're seeing here is that as the permafrost is melting, as the frost in the ground, where's that gone? The frost in the ground is melting, then the water that was frozen in that upper layer is now penetrating down into the mud, moistening it and turning it into a consistency of yogurt. So the bank of the community is sliding into the river as the permafrost melts. And if you look, this is the bank of the river, the top of the bank. If you look at the manager's house, the manager of what used to be the Hudson Bay Company is now the Northwest Company after they were bought out. This is what you see in front of his house, cracks in the ground. And you can put your arm down in those cracks I did that the previous summer and stuck a meter stick in, and you almost lost the meter stick. These are real cracks. This is not just superficial. These are cracks in the permafrost that are threatening the home of the Northwest Company's manager. And in fact, I put a little bit of a report together, and the Northwest Company has sent engineers up to look to find another place to move the house. They're going to pick it up and move it, and I hope they get it done quickly, because this ground could break and slide into the river at any time, and one doesn't want that to happen when there's somebody in the house. Just to illustrate how how climate change impact is interacting with other impacts, and one of the points to make about climate change, wherever it's having an impact, is it doesn't have an impact on its own. Climate change almost always is working with or working against some other factors in the area. And the reason I show you this is that we went to the Hudson Bay records, the archives in Winnipeg, and we're able to show that the manager's house, which is of course here and labeled, is now about 100 meters closer to the edge of the river than the Hudson Bay property was in 1815. In other words, about a couple of hundred years ago. This has been lost. All this land has been lost because of erosion from the river. And part of the reason for that is that the hydrology of the river is changing as the land is rising, and the erosion of the bank is partly because of permafrost melt and partly because of the hydrology of the river. So there's a climate change interacting with a hydrological factor in this case. Now, one of the most threatening aspects of the melting of the permafrost for Fort 7, and here is the community. This is the place we were just talking about. There's the bank that we were looking at. Just 11 kilometers downstream, upstream, sorry, 11 kilometers upstream, is the location of some slumps that I'm going to show you, which I first visited in 2009 with Andy Fionn, who was the director of the Geological Survey at the time, and had a spare seat on a plane and said, "David, you ought to come up and see these." So I did. And it was, oh man, what they're not there yet, but this is what they look like. This is what they look like now. And I'm going to go back to that fire slide in a second. These are 3 huge slumps, about 11 kilometers upstream from Fort 7. So the community is right here, community right here. And these are slumps due to melting of the permafrost, but there is a special reason for the melting of the permafrost here. And you can see that if you look down here, you'll see trees that are fallen. And this is actually a photo that I took a couple of years ago. So there's been 8 years for the leaves on the trees to die and so forth. But you can see how barren the ground is here compared with the thick forest here and the thick forest here. The reason for that is fire. And fire is becoming an impact in the far north, as well as the warming of the Arctic takes place, and the warming of the subarctic. This is from 2018. It's an astonishing image. This is wet peatland burning because it dried. It dried sufficiently for a lightning storm to set off fire like this. We're used to this in the boreal forest, but not in the wet peatlands of the Hudson Bay lowlands. This is a growing threat to the carbon storage, if one wants to look at it that way, but a growing threat to the communities of the Hudson Bay lowlands. It's a new impact, and it worked to weaken the permafrost in the neighborhood of where these slumps would occur. You can see the location there. We've looked at it, and the fire covered the ground where the slumps subsequently took place. So that doesn't mean that there needs to be a fire in Fort 7 for slumps like this to happen, because remember, Fort 7 is being built on. There are not trees there anymore. So there's development of homes and infrastructure and so forth has taken place. And that is part of what's disturbing the permafrost. What one has to hope is that that does not lead to the scale of slumping, which you see here, that was triggered by fire. But it might. And I've, as you might imagine, had some discussion with the chief and other decision makers about the future of the what you may call the river edge community in Fort 7. Now, part of what you could also see if you go to with the climate reanalyzer for today, Wednesday, April 21st again. And what we're looking at here was we're looking at the precipitable water, in other words, the water in the atmosphere that might rain. And 98% of the water in the atmosphere is in that very, very thin layer of the atmosphere that I showed you on the introductory slide. That's where the water is. But if you look at the amount of water which is ready to precipitate today over precipitatable, which is sort of, what can one say, on the verge of precipitating, sufficiently concentrated to be on the verge of precipitating, it's damn dry over the north, damn dry over where you're living, and up in Fort 7. If you look down on the scale on the right here, less than 10 kilograms per square meter, which sounds like a lot, but when you think of the whole thickness of the atmosphere, that's not very much. This is dry, and it has potential impacts for the future of the weather this summer. And I want to show you another piece of the reasoning for thinking about the weather of this summer. These are two maps. This is a map of precipitation relative to March of 2021 compared with it's compared with 2002 to 20. So it's comparing this March of 2021 with the March of the 20 previous years. And this is precipitation. And if you look down at the scale at the left here, you'll see that in March, over this is Grand Council Treaty 3 country, the southwest part of the north. This is sort of Sachigo Lake, and it's up to Fort 7. This is the Manitoba boundary here. Look at the figures for the low precipitation compared with the precipitation in March of the last 20 years, down at minus 75%, minus 50%. It's been darn dry. And at the same time, it's been warm. This is temperature. This is temperature in March compared with the previous 20 years. And the scale here, 3 degrees warmer, 4 degrees warmer than average, 3 and 4 degrees warmer, exactly where the dry ground is. This is a recipe for forest fires. And up here too, a recipe for forest fires. And if anybody wants to take a $50 bet, I will bet you that the fire season in the West will be severe this year, more severe than usual. These are the conditions which establish fire likelihood. And if we go on to the previous, going to January, we'll miss out February because we don't want to do all of the months of this year. But we go to January, so this is January compared with the previous 20 years. We're again looking at dry conditions, minus 75%. These browns, I don't know why they changed the scale from browns to grays and so forth, but they did. And this temperature, and look at these temperatures around Athabasca, up the Hudson Bay coast. How much warmer than the average January? 8 degrees, 7 degrees, hugely warm. You know, the Paris Agreement is talking about trying to keep the average temperature of the planet within 1.5 degrees of where we're at now, maybe 2. These sorts of differences, and Dan McKenney in the Canadian Forest Service office there in the Sioux has done work on projections for the future for Ontario, and Dan has projected toward the end of the century increases in temperature above this kind of 20-year reference level, 30-year reference level of 8, 9, and even 10 degrees. Huge, huge changes. And those huge changes are influenced by what's happening in the Arctic Ocean that we referred to earlier. The amplification of the warming from greenhouse gases by the absorption of energy by sunlight energy by open ocean, and that being re-radiated back into the warmed atmosphere. It's a complicated and threatening scenario, and you can see it in these maps from March and January. I guess I did put in February. I shouldn't have done. We don't need to go through all of these, but once again, dry, with a bit of extra precipitation above Fort 7. Anyway, let's get moving on. These are the locations of fires, 103 active fires in July of 2011. It was a bad fire season. And where was it? It was in the west of the province. And where are the dry and warm conditions that we've seen in the first 3 months of this year? In the west. So I will bet you that we're going to see a map of fire locations that's going to be just like this in this summer. And if you look around at, this is what you would call Big Trout Lake, High, Kitchener-Makazib, and Inawug, one of the places in the far north where there was a long-lived weather station and good observations of events like fires, and the elders in communities are great people to talk to about when climate or weather events like fires occurred. And if you look around, fire is part of the ecosystem up in the north. You have to expect fires, but the density of those fires, the frequency of those fires in 2011, and I think the likely frequency this year is abnormal, even when you look at the pattern around a place like KI. And part of what we found was we've looked at the dates of the fires in places like KI. If you look at the 1960s to 70s, the fire season was 3 months. 80s to 90s, 4 months. If you look now, it's actually 5 months, and it's even longer than, probably going to be even longer than that. We might even get the beginning of fire in April. So April, May, June, July, August, and the fire season going on after the university students, which help so much in the summer firefighting, after they've gone back to school. South of the border, where the conditions, those dry conditions that I showed you for March, also occurred, they formally initiated their fire season on April the 4th. April the 4th. One of the consequences of fire seasons, or fires, is not so much the burning of structures, but the smoke and the health impacts on people with respiratory issues, and the importance of evacuation. And one of the ways for adapting to an increased fire season, a longer fire season, more frequent fires, is to in fact have an evacuation plan that's ready to go. That's very, very important. And this is an evacuation from Yabmatung in 2006. And it's so important to get people out of communities when smoke begins to invade like this. It's not just the flames, it's the air quality. Winter roads are also being affected by, as you all will know and would easily guess, being affected by the increased warmth in winter. KI is a community that we've spent some time looking at. We don't have the research data plotted up yet, but I can tell you that Since the 1930s, I'm just looking quickly at some notes that I've got here that I was just making as I checked out the research data. The records go back to 1937, and part of what's happened since 1937 to now is that 3 weeks from what you can call the winter road building season. And what we've done is we've not added up the freezing degree days. What we've done is we've said, how many days are there between the first 5 consecutive maximum -10 days and the first 5 consecutive days of 0 or more, looking at that period as the beginning and end of winter road construction and driving potential. And KI has lost 3 weeks since 1937, and you might think that's not a whole lot. Well, in some years, the number of days of the exceptional winter road season in KI was down to 50. Some years it was up to near 100. Losing 20 out of any of that number is important, and if you project to the 2050s, the season is likely to go down by another 2.5 to 3 weeks. So winter road season is getting shorter, and the conditions that winter road builders like, which are 10 consecutive days of consecutive nights, I guess one would say, because that's when the temperature gets coldest, of -20 is what they want. That isn't going to happen in the future, except in the very farthest part of the north. And here's the winter road system, very important. And if you're in Fort 7, looking at the top 2 dots there are Pewanak, which is the other one to the east, up on the Hudson Bay coast. You're looking at having to bring your diesel in 1,100 kilometers from Winnipeg. That's how the diesel gets into to Fort 7, and this is how it gets in there. You don't send tanker trucks. You have to take the tank and put it on the back of a truck like this. And you need good, thick ice if you're going to cross water bodies with something as heavy as this. So losing those -25 days is -25 degree days is darned important for a place like Fort Hope. It's important, and Fort Hope is trying to counteract the consequences of not being able to bring in fuel from Winnipeg by, first of all, abandoning, if at all possible, the generating station as the main source of energy. Backup energy, okay, the main source of energy in the community. And you can see solar panels on the heavy equipment shops down at the bottom left. And you can also see the beginnings of a solar farm, which is now finished actually. And they would like to be able to flick the switch, but the final inspections can't be done because of COVID and the restrictions on people coming in to do those final inspections. But it's important to realize that there are technologically innovative adaptation solutions to the loss of winter roads in the north and the loss of the ability to bring in fuel, unless you fly it in. But you can imagine how many $1 million it costs to fly in fuel for a community. Interestingly, Fort 7, I won't dwell on this, but there was a wind turbine. It was one of the first places in the province to have a wind turbine. It was dismantled in 2010 because of maintenance issues and because batteries are not good enough to store the power. Just an interesting little sidebar, but an illustration of the innovative thinking of the community, even over 10 years ago. Important for Kitchener-Makersip. This is KI. It brings in construction materials, and you'd better make sure that everything you need, right down to the last nail and screw, is in the order. Because if you suddenly find that you need another 100 pounds of nails, you can't just go to Home Hardware and buy it. You've got to get it. Send an invoice. You've got to get it. Send an order. It's got to be flown in and so forth. The logistics of a project in the far north are not as easy as we're used to. Anyway, I need to speed up here so that we're not going hugely long. And this is a measure of the increased rain in winter for Ki. And you might say, well, what's the difference between 1 day and 4 days? Well, the difference between 1 day and 4 days is 4 times as many chances of flooding your infrastructure because the ground is still frozen. Remember, this is winter rainfall. This is not summer. This is not when the rain can soak into the ground. This is when the ground is still frozen. And 4 days, 4 occurrences of that in the 2050s is 4 times the risk of flooding some of your important buildings and homes too. This is another threat that's on the it's on the list for Northern Ontario, for the forest of Northern Ontario. You will probably all know that the lodgepole pine forests of BC were attacked by the pine beetle, but that the pine beetle didn't move to the east because the temperature, the winter temperature on the ridges of the hills was sufficiently cold. I think something like -10 for 5 days was approximately what was needed to kill the mountain pine beetles. They didn't cross those ridges, but the warming climate has enabled them to do that, and they have begun to spread to the west. And there's very considerable attention to monitoring the movement to the west. Not yet, I think, into Manitoba. In fact, I'm sure not yet into Manitoba. And it's moving slowly, and there are ways that by thinning the trees, one can, I understand, prevent the rapid spread of the pine beetle. But as for impacts in the future that one needs to be prepared for on a large scale, even beyond just a community scale, the pine beetle is one of them. Now then, I want to make sure that when I'm done here, which is very soon, that I'm leaving you with an opportunity to go to research some of the future for Sault Ste. Marie. This is the Climate Atlas. And you can see the web address up the top there, climateatlas.ca. There's also a federal climate data .ca site, which you can go to find projections of future climate. But the Climate Atlas we found easier for people to navigate and easier for people to see the data. It's very visual, and also the numbers where there are numbers to be given are well displayed. So you can look up Sault Ste. Marie, go to the Climate Atlas, click on the square that is Sault Ste. Marie, and then there are a whole host of climate factors that you can look up. And I pulled this one out, length of the frost-free season. And you can see that compared with 20, 30, 40 years ago, the frost-free season is going up by a couple of weeks, 3 weeks even, which means that you can plant your cabbages earlier, plant your strawberries earlier, and there's an opportunity for greater growth of vegetables, not only in the Soo, but north of the Soo, and into those sorts of communities that I was just speaking about. Fort 7 does have some people who grow potatoes, and potatoes are pretty resilient. Sandy Lake has a 92-year-old fellow, in fact, he must be 94 by now, Percy Ray, who grows acres of potatoes. There's a place called Potato Island off Webequie, where they grew their potatoes on an island in order to keep them away from the dogs. And there's increasing potential for food security as far as vegetables are concerned, as a benefit of climate change in the north. So not just in Sault Ste. Marie, but in the communities that I just mentioned. This is also a change that's coming, and I've taken off the label for Sault Ste. Marie so that we're not crowding the map with that on, and you can easily do that when you're messing around on this site yourself, the very hot days are a threat to the good health, the well-being of not just very young children, but also the elderly. This is a serious health threat that's in the offing. And in Sault Ste. Marie, 4 times as many days of over 30. And remember, some of these days might not just be plus 30, 31 or 32. They may be 36. They might be 35, 34. If any of you have friends or relatives in India, they'd be very pleased if their summer days were plus 30, 34. They're dealing with plus 40, 45 degree days. So heat stress and death from heat stress is an increasing risk in many parts of the world, even in Sault Ste. Marie. And talk to people in Boston. I can't remember the year, but there were thousands of people died from heat stress, heat stroke, and heat illness sometime in the last 25 years, I do believe. This is a real health threat for the future. And the Climate Atlas is an excellent tool for you to explore yourselves, or if any of you are teachers, or you have friends who are teachers, this is dead easy for kids to navigate and to put stories together. What is the story of the future climate in my community, Sault Ste. Marie? Or maybe you want to get them to look at Winnipeg or Regina or another Canadian city. They can put the future story together. And it's not just the hot days, it's not just the rainy days. There are a whole lot of other factors. There are about 30 factors that kids can look at, and you can see what the difference would be in the end of the century if, in fact, we do reduce our greenhouse gases so that it's less climate change. An RCP, representative concentration pathway 4.5, for those of you who know the numbers, in the future, the benefits of emission reductions are going to be felt in these plots by where you move this blue circle. And here are the 5 themes within which the data are listed. We're working with 6 councils, Grand Council Treaty 3, and then 5 tribal councils, and you can see the people that we pay for them to be part-time, what we call climate change specialists in those tribal councils. Geneva up in Grand Council Treaty 3, and then the 4 of us on the team at Laurentian. We are a team that's collaborating with tribal councils and communities to help them prepare plans and adaptation options for health. I just talked about heat waves. This is a poster that we've prepared that could go on a wall, or it could be a handout for discussions in communities about what are our priorities. What are we going to do in order to be prepared for very hot days, an increase in very hot days? That's the front of the handout. And this is the back of the handout with more notes. One has to begin to look at adaptation, and one has to begin to look at adaptation that's appropriate for those communities, that they can talk about amongst themselves and make decisions. And that's the kind of work that we're doing with them, and also preparing what we call an adaptation framework, the kind of process that a community would go through in order to pick the adaptations which are important. It's all very well to talk about the impacts, but that doesn't get you anywhere unless you then go on to talk about the potential adaptations. We run a Facebook page as well as a website and a Facebook group for the First Nations themselves. And what we're aiming for is to help the communities of the North become climate resilient in the future. Meetings to talk about options, growing vegetables for food security, using solar panels to avoid having to rely on diesel transport over winter roads, getting kids involved, because they're the ones who are going to have to deal with the problems in the future, and engaging elders to speak about their experience of finding berries and where to go to look for the food resources that come from the land in the north. And that, I think, is my last slide. Too long, but that's me. So I'm going to put off my screen here. I'm going to stop sharing the screen if I can get to the button at the top here. Where's it going? Screen sharing. Stop. There we go. So I'm happy to take questions. I don't see anything in chat here. In fact, I don't see a chat box.
I believe we do have several questions. If you want, I can go through those for you.
There we go. I found the chat box.
Okay.
Well, we're not actually working with any urban communities in the north. They're all what you would call rural, but of course that is an important distinction when one comes further south and into the sort of country that we have here around Sudbury. I think the mitigation efforts, the cutting of greenhouse gases, is something that needs to be done through policy on a large scale. And I think that if provinces, or especially provinces who have so much more jurisdiction than the feds over many parts of public policy, the provinces need to be on board. And if the provinces are on board, then the kind of actions that would help urban communities and they're more, what can one say? I don't want to say industrialized, but they're more integrated economic activity. That could happen, but it depends upon provincial policy. It really does. So are we just to adapt? No, we're not just to adapt. If we just adapt, then we're going to lose the battle. There are limits to adaptation. And it's not something that I've talked about, but it is something that we do talk about with communities, limits to adaptation. And the only way to be able to live within those limits is to make sure that we reduce greenhouse gases so that the adaptations don't have to be so deep. Now then, is current research funded exclusively by the government?
David, I can read the question, and maybe just.
Sure. Yeah, I'm looking at
the next question was: the rural-urban divide is among the deepest in terms of support.
Yeah, I answered that one, Greg.
Sorry.
I tried to anyway.
Okay.
That one here, yes, I tried to answer that. It is a deep divide, but it can be overcome if with provincial policies and backed up by the federal government. There's no reason for there to be a divide. It's just that the resources that are available to urban communities are more easily mobilized. And then just going on to this one here from Gabrielle. As I say, there are limits to adaptation. Relying on being able to adapt is not enough. We'll arrive at those limits eventually. And if you remember a couple of those trends that I showed you of loss of cold days in Fort 7, for example, where the trends divide in the 2050s into those that reflect real effort to cut greenhouse gases and business as usual and no effort to cut greenhouse gases. That's when the trends begin to separate, and it's then that the limits to adaptation become clearer and clearer and clearer, and we need to realize that we cannot just adapt. That's not possible. Sorry, Greg, if I could just carry on here. Current research funded exclusively by government. The answer to that, I think, is no, but the big money needs to come from government because these are national policies. and provincial policies. So from the national and the provincial government, the money is big, it is huge, but it also is money that can be invested in ways of reducing greenhouse gases that develop jobs. And you're going to find in the discussion that comes out of the Earth Day meetings that that happens. Forestry and mining industries contribute for funding. Well, you know, forestry especially is dependent upon a healthy ecosystem, a healthy forest. And forestry companies, I think, are indeed the big ones, the thoughtful ones, with a long-term view of the future, are indeed, I think, looking at how best to contribute to greenhouse gas reduction activities. And remember, it's trees that are put into buildings that are used for construction that are also part of storing carbon. Our lake center at the university here used wood built out of Ontario wood. We store 180 tons of carbon in our building. What can municipalities do to fill gaps? They can only take local action. The really strong action has to come from governments. It's how you vote that'll make a difference there, I think. Now then, what kind of investments would be required to answer the outstanding questions about climate adaptation required in Northern Canada? Close to a comprehensive understanding? I think the answer to that is no. We've got a long way to go to come to a comprehensive understanding, especially of adaptation in the real far north, the Arctic North, the Iqaluits and so forth. A long way to go there, and the limits to adaptation are there. So easy to see. If the ice isn't thick enough, people can't travel on it. The ecosystem's upset because the seals have to come onto shore instead of being able to live on the ice. And once they're on the shore, then they're fodder for predators, and not just for human hunters, but for wolves and for polar bear. Easy to capture. What kind of investment? Well, big investment. Frankly, big investment, and especially in the Arctic. The Arctic is warming at twice the average rate of the planet as a whole, because of that Arctic warming, the warming of the Arctic Ocean during the summer, and that heat being stored there and then passed back into the atmosphere, and is coming back to whoops. Yep, couldn't come up here. Oh, thank you. Yes, I'm certainly passionate about this, I must admit. If you have any questions, feel write them in the chat box. Sorry, Greg, I sort of got on top of you there and went ahead.
No problem, David, no problem. So I think, yeah, if there's any other questions, if anybody's got anything they want to add to the chat box.
Can I just comment on geoengineering? Don't go there.
Sure. Yeah, don't go
there. If the notion of, for example, putting particles of some kind in the atmosphere in order to reflect the sun's energy so that we don't receive as much, so the earth doesn't get warmed as much, so that the re-radiated energy from the cooling earth is less, and so there's less for the greenhouse gases to capture. Those sorts of schemes are not, I think, what's important. I do think that it's important to be looking at ways of every possible way we can to store carbon. So the lowlands of the north that I mentioned just a little bit, because we talked a bit about Fort Severn, but they extend right away over to James Bay. There's an enormous area. I forget the exact number, but it's hundreds of thousands of square kilometers that is important carbon storage, and we need to protect that ecosystems, the ecosystems of the peatlands, and do whatever we can do to protect them from drying and burning, and to be maintaining their capacity as peatlands, and to store carbon. And the same applies to wetlands. It's not just the peatlands of the north, but it's the wetlands of the south. Wetlands store carbon, and we need every bit of carbon storage we can get. But that's what you might call a natural solution to the issue, and not what is generally understood as a geoengineering solution. I would not I would not be persuaded that geoengineering was the way to go. We've got to go the harder way and cut emissions and not throw stuff up in the atmosphere to try to change the system. We don't understand the system well enough, and we probably would get ourselves into even more trouble if we tried to go that way.
Chat. Those are people writing in comments.
Pardon?
Pardon me, is there a question there?
How close are permafrost methane releasing? Well, they're close. They're close. When you see a fire up near Fort 7, like that photograph that I showed you, when you see in here about fires in the peatlands, you're seeing the tip of the iceberg, and the warming of the peatlands results in a change in the microbiology of the peatlands, which begins to release more methane. So I think we're close to that tipping point, closer than we probably realize, and closer than we want to know. But it's a very dangerous tipping point, because methane, as you know, although it doesn't last in the atmosphere as long as carbon dioxide, when it is there, it's a much more potent greenhouse gas than carbon dioxide. It's you put your finger on an important issue, very important issue. Now then, is there another one here? Yes, there is. Oh, the impact of ring of fire development. Well, that sort of goes beyond climate change, doesn't it? How to put that quickly into a few sentences. I think one of the issues to be dealt with is the roads into the ring of fire, which lead to they lead, for example, to the potential for not just people but for wildlife such as wolves, predators, and so forth, to change the balance of the large animals in the north. But the other issues that you're probably thinking of are the release of contaminants from tailings and from other sources of contamination in mining operations. I understand that there are plans to put the tailings underground rather than into tailings piles, but it seems to me there are limits to that. So I think that one of the implications for the downstream communities like those on James Bay, but it's especially those on James Bay where the major rivers flow, for example, the Albany, it's so important to have very, very careful and monitored plans to limit, to prevent the movement of contaminants from the mine waste and from the exposed rock and rock debris that comes from mining. There are too many impacts to put into a couple of minutes of an answer to that question, but they're enormously important. And part of what I hope is that the environmental impact assessment is indeed thorough. And there are some there are some people who are questioning how thorough that's going to be. We have to cross our fingers and not just hope, but argue for a very thorough environmental impact assessment. And what else is here? That's the last question I see there. Greg, do you have anything else?
No, I don't see anything else here. I think that pretty much covers it. Thank you very much for that presentation. That was excellent.
Oh my goodness, you have Paul Hazlitt for your next speaker. Oh, that's really
Can I
good.
ask a question?
Sure.
Go ahead.
Okay, actually I have about 3 questions, but I was trying to get into TAP and I'm using a new machine, so I couldn't figure it out. The first one I wanted to ask you about positive feedback. So you mentioned the disappearing of the polar ice.
Yeah.
And with the disappearing of the polar ice, you have more open sea. It absorbs more heat from the sun, so that speeds up further melting of the polar ice. So there's a positive feedback there.
That's right.
And it's sort of like we have with COVID, actually, this positive feedback. But often, and what I mean with COVID is that the more people are infected, the more they can spread the disease, and then the more are infected. And so again, you have a positive feedback.
Yes.
So with positive feedback, often there's associated tipping points, at which point the whole global warming, the whole Earth warming kind of gets out of control. And you referred to this 1.5 degrees or 2 degrees.
Yes.
And I guess that's kind of a line that the UN drew in the sand. I don't know if there's any real scientific evidence behind exactly where that is, because I suspect that there's quite a group of different tipping points. We don't know how they're going to interact. So basically, we're rolling the dice right now by not controlling the greenhouse gases in the atmosphere well enough.
You're absolutely right with all of those points. You're absolutely right. And if I were to have to tick a box or make a bet, I would bet that the science behind the potential to achieve 1.5 and the certainty or the stability of the future of the planet if we do achieve 1.5, the assumption that that will be satisfactory or enough to maintain the ecological integrity of the planet, I think that's on shaky ground. I agree with where you're coming from, that it's on shaky ground. We just don't know enough. And you mentioned COVID, and I suppose what I could also say is that if we learn as much about the inability of 1.5 or the insufficiency of 1.5 as a target, as we've learned about learned about COVID in the last 12 months, my goodness, I will be in trouble. We learned a hell of a lot about COVID, and we've got a lot more to learn about the effectiveness of 1.5. So I agree with you.
Okay, well, thank you. I have another question, which happens to do with the nature of carbon dioxide, the main greenhouse gas.
Yep.
And I guess it's known to disperse very, very well. So an implication for that is that if we clean up Ontario in terms of mitigation, we may still be getting a lot of spillover from our neighbors, either to the south or from China or anywhere around the world. So it almost is going to take a global effort to really do mitigation in a way that may let adaptation take its course. And so to do this mitigation, it seems to me that we almost have to do something like, it's almost like Biden almost proposed it just in the last couple of days, a sort of world agreement where, or he's going to punish people that want to trade that don't abide by sort of climate considerations. And it seems to me that that's almost the only way we're going to get at this globally, is to get an agreement on that kind of level.
Yes, you're right. It has to be global. It has to be global. And part of just going back to your last question, part of what we don't understand very well, or part of what we don't realize, is how much of the energy that's being captured by greenhouse gases is being stored in the ocean. More than 90% of that captured energy is going into warming the oceans. And the monitoring of the warming by depth, the depth to which warming is now taking place is huge. The oceans are going to be the oceans are the habitat for fish, and we are not just, obviously there are freshwater habitats too, but the ocean living fish, the ocean living ecosystems are more threatened than the land-based ecosystems, because that's where most of the warmth is going, and not just warmth being stored, but acidification as well. Coral reefs, for example, are severely endangered, and coral reefs are the source of the ecosystems which feed, I forget what the percentage is, but it's several tens of percent of the fish that are used for food that are taken from the oceans, and the coral reefs are dying because of the acidification of the oceans from carbon dioxide. So it's the oceans they're not talked about enough. They're not talked about.
Yeah. I think another thing with the oceans is that they also have kind of a long-term turnover.
Yeah.
So that you may have certain parts of the ocean will get warmed. It'll turn over, may come back in 50 years or something, but that means we'll be starting in 50 years with a warmer ocean. So this is part of the reason why they say that we're already committed to so much warming in the future, even if we stopped everything right now.
Absolutely. And when you look at the Gulf Stream and the importance of the warm water that moves up towards Scandinavia, past my home country in the UK, that warm water needs to lose heat and become cold and dense and sink and return toward the south. And the warmer the north becomes, the less effective that heat loss is, and the less effective the turn of the Gulf Stream. So we're having an effect, and it doesn't happen overnight, and it's less easy to see an effect on exactly what you're speaking about there, the ocean systems, the complex and the slow moving ocean systems that are so important to the life of the oceans. Yeah.
So I guess another factor with climate change, or global warming, as we used to call it, is the warming in other parts of the world. And I guess the U.S., I think it's the U.S., might be the Army or sort of national defense, did a study on this, apparently, and they were looking at this as in a lot of areas, you might have the sub-Saharan areas, or the Middle East. You'd basically start getting it too dry to really do agriculture. And they also are having conflicts. So you're talking again about these two factors coming together.
Yep.
And that's a source of all sorts of migration.
Yep.
And this migration is not welcome everywhere. And clearly it seems to be sparking a lot of populism in our politics. Yep. And this populism has been very harmful. Just look at what happened in the last 4 years in the US.
Yep.
And so it almost brings to mind the idea that we as citizens in Ontario have to be aware of what's going on in the rest of the world and how it might be affecting climate change. And we also have to be prepared to vote accordingly. Now, I'm not going to say who to vote for or anything like that, but I think that's an important issue that I think people can get too tied up in just their local politics instead of looking at the big picture, but how the big picture can come back and basically put constraints on what you can do locally.
Yes, what you're speaking about are climate change refugees, and
Yes.
putting your to be looking at sub-Saharan Africa is exactly where you should look. I saw some numbers. It's too far back for me to remember exactly what they were, but it was in tens of millions of climate change refugees already, who had to leave their what you might call their home territory because they simply couldn't live there anymore. They couldn't grow the food because of drought. If we'd taken today's temperature picture on that globe from Reanalyzer, the second picture I think I showed you, and we'd gone down to look at Africa, the temperatures in sub-equatorial, just south of the equator in Africa, are up in the high 40s and early 50 degrees. Well, you know, agriculture under those sorts of conditions is virtually impossible, virtually impossible. You're without surface water, and even down in the States, they're running their aquifers dry by using water far too liberally, by spraying it, which is a wasteful way, because 80% of the water that's sprayed over fields evaporates before it reaches a plant.
Yeah.
It's waste. So there are all sorts of ways that we have to improve the use of the distribution of water. And it's shameful to see that happening when people are having to leave their homes in sub-Saharan Africa because there isn't any water. There's no water at all for them. But yes, it's a refugee problem really, rather than an immigration problem.
Yeah. I had one other question was, I used to work on looking at the spruce bug worm, which was an insect that, it does a lot of damage in Ontario from time to time. And one of the things with spruce bug worm is it's a defoliator, but it takes off only the most recent. So often a tree might have 8 years of foliage or 5 years of foliage, and spruce bug worm typically will only take off the most recent year. So the tree still looks green if you're flying a satellite over it. So what you really need to do is have people on the ground that can kind of check up on the satellites. And one of the things that I've been wondering about is involving, say, young students and so on in something like citizen science, where they could be the people on the ground, especially in these remote areas where basically all we can do is fly a satellite over or get some communication with students on the ground. We don't have enough manpower to go up there and check everywhere where a satellite is gone and the forest looks green. And this probably applies to all sorts of other aspects of climate change happening in Northern Ontario and remote areas where, frankly, it's only natives, and they already have a big social problem there. We hear about with a lot of drinking, a lot of drugs, and maybe this would be a way of giving them some purpose to go out and help on climate change. And it won't work for everyone, but maybe it would help a few.
I think that you would find that the living relationship that First Nations have with the land is a very powerful base, very powerful foundation for the sorts of observational skills that you're speaking about there. My experience in the north has not. I have not seen the problems of drugs and alcohol. I can think of some communities which are dry, for example, where you cannot get into the community unless you go through an inspection station, and if you've got any whiskey with you, it's gone. There's a consciousness of the importance of protecting their bands against the issues of drugs and alcohol. I think that those are the sorts of problems that you see in cities where people have moved to and are subject to the pressures of a city.
Okay, well, it might be easier then to get them involved.
Yes, it might very well be. I like that idea, and I've actually made a note here that I'm gonna tuck in my head and see if we can turn that into a project or two in some places. Yeah.
Okay, well, good luck with that, and thank you. I enjoyed your talk.
Well, thank you. I enjoyed your questions. They're thoughtful questions. They really were.
Great. Thanks, David. Unless there's any other questions right now, what I could do is just go back to the agenda, actually, and I just wanted to touch on Sioux Climate Hub's involvement. We do have a couple more talks coming up, a couple more presentation or series coming up. Actually, one on May the 26th, which is The Life Inside the Soil, put on by Paul Hazlitt. So that'll be an interesting discussion. And then cycling, I think more around how we're going to use cycling to decrease our carbon footprint. So Kim Chapman is going to do a talk around that on June the 23rd. But first, maybe before we move on, David, thank you very much for that presentation.
My pleasure.
Much appreciated. The Hub is always looking for these kinds of talks, and the way that you've described everything and put into a global and then a local context in Sault Ste. Marie is fantastic. So thank you very much for that.
My pleasure. My pleasure. Great. Thanks very much, everybody. Bye.
Thank you.
So anybody still left on the call, I just wanted to mention, if you're interested in becoming more involved in the Sioux Climate Hub, feel free to send an email to the Sioux Climate Hub at gmail.com. You can reach us through there. And I understand that they're looking for a regional organizer for the climate hubs. So again, just reach out to us through siouxclimatehub at gmail.com, and we can certainly, if you're interested in something like that, or even within our own membership, we can explore that option. So thank you very much, everybody, for attending, and look forward to seeing you again on some of the future presentations. Thank you.